Alright, what's up guys? It's Probability by Pitman, Chapter 1's review section, problem number 16. Okay, so a dormitory has n students, all of whom like to gossip. One of these students hears a rumor and tells it to one of the other n-1 students picked at random. Subsequently, each student who hears the rumor tells it to a student picked at random from the dormitory, excluding, of course, himself, herself, and the person from whom he or she heard the rumor. That's a very important blurb. I was very confused until I actually paid attention and read that part. Okay, anyways, let PR be the probability that the rumor is told R times without coming back to a student who has already heard it from a dormitory mate. So P1 equals P2 equals 1, and Pn equals 0. Julio. Okay, so let's just start from the first dude. So n minus 1 over n minus 1. So the reason it's this is because he can tell the rumor to anyone besides himself, hence n minus 1. And then no one has, besides himself, has heard the rumor yet, so he can just do everyone. So n minus 1 over n minus 1. Cool. Alright, so the second dude is n minus 2 over n minus 2. Why is this? Because he can't tell himself, and then he can't tell the dude before him. So n minus 2 is the top. And then there are n minus 2 people who can tell it to, potentially. Sorry, so yeah, so n minus 2 because there's n minus 2 people he can potentially tell it to. And then at the top is n minus 2 because there's no one he needs to exclude. Sorry, that was a little confusing, but I think I got it there. Alright, so the third dude throws in is a little different. Sorry, not n minus 3, it's n minus 2. He can tell to anyone besides himself or the second dude, but he can't, for our condition, where it's told without coming back to student has already heard it, he can't tell to himself, second dude, or first dude. Alright, cool, so let's go to the fourth man. Exact same pattern. He can tell it to anyone besides himself or the previous dude. However, we have to exclude himself, third dude, second dude, and first dude, because we can't let anyone who's already heard the rumor um, hear it, right? So you just keep doing that pattern until n minus r over n. Oh, it's a little messy. Until n minus r over n minus 2 dudes. So the rumor would be told r times, and our conditions would still hold true. Cool. All right, now the slightly more interesting part, where we have to approximate this probability given n equals 300 and r equals 30. So we'll use this approximation where log 1 plus x is about equal to x. Coolio. So let's do log PR, just do the log of, and I won't write out the whole thing this time, let's just do n minus 1 over, sorry, we'll leave out the ones. N minus 3 over n minus 2 times n minus 4 over n minus 2. Oh, messy again. Let's redo that. Times dot 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 times n minus r over n minus 2, which is our last term. Cool. Okay, we can split the terms. And since it's multiplication, we can add the log terms. And if it was division, we would be subtracting them. Cool. Okay. So now we can do a little manipulation. We can say that's equal to log. We want to make it look like 1 plus x, right? So we can say n minus 3 over n minus 2 is equal to log 1 minus 1 over n minus 2. So 1 would be n minus 2 over n minus 2, minus 1 over n minus 2. So n minus 2 minus 1, n minus 3, all over n minus 2. And then we can do the same for the rest. So log 1 minus 2 over n minus 2, where 1 is n over n minus 2 over n minus 2. So minus 2 over n minus 2 would be n minus 4 over n minus 2. If that makes sense. And we just do that same pattern for 1 minus, so for the previous two, we just did minus 1, minus 2. So it'd be minus r, I believe, over n minus 2. Okay, my bad. I did not do my math right there. Um, Sorry. So this would instead be, scratch all that out, plus log 1 minus, so this is n minus 2 over n minus 2. We wanted to simplify to n minus r. So we'd have another negative 2, so plus 2, so it cancel out the 2, and we'd have r. There we are. Yeah. Okay, my bad. Sorry for that mishap. Okay. So now that we have this, we can actually use our approximation log 1 plus x is about x. So we can take our x term, which, for example, this one would be negative 1 over n minus 2, and just do that. Pretty simple. Alright, now that we have that done, um, we can try and simplify it a little further. So we can actually use like the Gaussian summation. So let's first factor out this part. And boom, we have 1 plus 2 plus dot 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 all the way up to r minus 2. So the Gaussian summation is as follows, where you have 1 all the way to n, it's equal to n times n plus 1 over 2. Or sorry, not comma, 1 plus dot 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 plus n. It's equal to that. And fun fact, apparently Gauss discovered that when he was 10 years old. So if you ever feeling dumb, um, I guess that makes you feel dumber. My bad. Okay, anyways, okay. So we can apply that formula. And remember, n is the last term of the summation. So it would be, the last term of our summation is r minus 2. So it would be r minus 2 times r, sorry, I just wanted to double check that I had the formula right. Okay, cool. R minus 2 times r minus 1 over 2. And boom, we have a generalized version that we can use to approximate of our original probability formula using log 1 plus x is approximately of x. So now we can just plug in n equals 300 and r equals 30. Remember log is equal to, I guess we can do it now, why not? Okay, log PR is equal to negative 1 over 298, since 300 minus 2, it's 300, yeah, and then r is equal to 3. So times 28, 29, 2. And then we can just get rid of the log by using e. So yeah, PR is equal to e times negative 28, 29, all over, so 596. And that should be our answer. Alright, cool. Thanks for watching, and I hope that helped.